Hi everyone, my name is Nivedita and I'm from Mauritius. Today at this Global BIM Summit, I will be sharing on machine learning applied to building information models. The outline of my presentation will cover machine learning and construction, types of machine learning, application of machine learning to BIM, BIM model representation for learning applications, uncertain present, BIM, AI, and construction tech. Machine learning and construction. As you can see, machine learning consists of 1. Prediction, 2. Decision making, 3. Tools, 4. Strategy, and the last one is society. In this presentation, we will apply machine learning in the context of an architect. For the first section, we have prediction. Prediction is a process of filling in missing information by taking data and using it to generate predictions or information that you don't have. Architects can input floor plans data sets into generative design software that's driven by AI to create building footprints according to the requirement of clients. Next section is decision making. Making a decision requires applying judgment to a prediction and then acting on it. However, there are limitations as most AI machines and equipment do not tolerate uncertainty, and they are designed to operate in a rigid environment. Therefore, humans are still required to make judgment. Let's look at the last three categories: tools, strategy, and society. The actual implementation of AI is through the development of tools. These workflows consist of tasks, which are a collection of decisions. AI may shift the emphasis of specific skills required for a particular job and lead to the reconstruction of job with certain tasks added and others removed in the context of an architect. People will be able to spend more time on decision making rather than drawing up floor plans. Also, prediction and judgment are complementary. When the use of prediction increases the value of judgment. Let's dive into types of machine learning. As you can see, we have three types of machine learning. The first one is supervised machine learning. As the name suggests, you have to supervise your machine learning while you train it to work on its own. It requires labeled training data. Next is unsupervised learning, wherein there will be training data, but it won't be labeled. Finally, there is reinforcement learning, where the machine learns on its own. Application of machine learning to BIM. Machine learning has been demonstrated to be an effective approach to automate processes and extract useful insights from different types and sources of data. It has a capacity to convert raw data into the knowledge requires the ability to convert data into information by making sense of it in a particular context. This work adopts a learning perspective for machines to learn from data stored in building information modeling. Machine learning is a scientific domain including several computational techniques which open new horizons in the learning process to the extent of finding patterns that is sometimes difficult to be discovered by the human eye, and that could be insightfully challenge the current construct of AEC. Studies conclude that the application of machine learning from BIM models requires meeting specific criteria, which are yet to be proven, a challenge in the context of the sector. Machine learning needs a large amount of input data to operate. Secondly, the data also need to be appropriately collected, filtered, and stored. Thirdly, the data shall be converted into information to facilitate the learning process. BIM model representation for learning applications. As you can see, building models are stored in one of the three ways. None of these formats are directly compatible with pattern recognition or machine learning. In all existing applications of AI that use BIM information, whether as complete models, assemblies from models, or model component, users must extract and compile the relevant information anew for every use. Extraction generally requires export of tabular schedules of objects and their properties of IFC files. A core problem with these methods is that meaningful information is lost in transition. Perhaps most significant is the loss of relationship between objects that are available in the BIM software representation, but that cannot be exported easily in tabular schedules and are generally absent entirely from IFC export files. Uncertain present BIM, AI, and construction tech. As you can see, there are three types of construction tech area: automated design and code compliance, construction set out, automated project performance, monitoring and control. Automated design and code compliance. Although the advent of BIM has made commercial code checking application viable, the core technology has not changed fundamentally. The challenge posed by large numbers of applicable design and building codes and the frequency with which they are updated has not been solved. The progress in code checking will require overcoming these barriers, and new approaches and technologies will be needed. Among the most promising is the application of machine learning to evaluate designs on the basis of the training data of known results from human experts. Construction set out. BIM to field information delivery has largely been solved with regard to delivering BIM information to personnel via mobile computing devices. All the major BIM platform companies offer solutions, most of which originated with disruptive construction tech startup companies, whose solutions were acquired by the established BIM companies. Tools that present model information using augmented reality are also available. Automated project performance, monitoring and control. This area is rife with solutions offered by both software and hardware vendors and startup companies. Applications range from inspection systems, allowing inspectors access to data before, during, or after the inspection process, access to recording functionality to collect site data, to control systems that enable the control of safety, site traffic, resource and storage utilization, planning and measuring system, logistic and layout planning, production monitoring, and others. They use one or few data acquisition technologies and interpret that as best they can into useful construction management information. Thank you for your attention.